effect of capacitance of MOS. Okay, we studied last class how was the MOS capacitance in the cutoff region, in the linear region, and in the saturation region. And we know what is the gate capacitance at each region. Okay, now we'll try to analyze it. Okay, now I tabulate it. If you want to analyze, I'm just tabulating it with respect to three major gate capacitance. One is, you know, the three gate capacitance available. One is gate bulk, gate drain, and gate source. Okay, so I'm finding out what is the total capacitance of each region. Okay, so there are three regions. One is cutoff region, linear region, and saturation region. Okay, and basically I'm drawing the analysis in the form of a graph, right? So the graph will have uh, capacitance value on the y-axis. In the x-axis it will have voltage, input voltage, which is nothing but the gate source voltage, right? So this is the threshold voltage. Below the threshold voltage, all of you know, this is the cutoff region. Okay, in between Vt and Vt plus Vd, you have your saturation region, and Vt plus Vds will give you the linear region.
Sir, sir,
Yes,
could you please zoom in the slide, sir?
little small, eh?
Yes, sir. It is not visible.
How do I zoom in? Is that okay, ma?
Yes, sir. Now it's fine.
Okay, thank you. Try to make it a little more bigger. Yeah. Now, when you look at the capacitance, as I already told you, gate bulk, gate drain, and gate source. These are the three gate capacitance available. Now, with respect to the cutoff region, this is the cutoff region. Okay, this is the saturation and the linear region. So these are the three regions. Now we need to calculate the capacitance, total capacitance of the cutoff region. So total capacitance is going to be, this is zero, this is zero. Only this voltage will be, this capacitance value will be there. That is CGB, gate bulk capacitance. Okay, and the value of gate bulk is 1. You see the orange line. So the orange line indicates CGB. Okay, that is gate bulk capacitance. So the value at the cutoff is 1. Okay, the other two are having the value 0. So it is basically the zero line. The green and blue are the gate drain and gate source capacitance. So both the capacitance have zero value at the cutoff region. Okay, is that clear? The first region, all of you. You have only the gate bulk capacitance ma. The value of gate bulk is 1. It is given to be value 1. And the other values of the capacitance of gate drain and gate source are basically 0. Right? Now, going to the second region, that is saturation region, I'll take this thing. You have gate bulk 0, gate drain 0. Only gate source you have, that is 2 by third value. So this is 2 by 3 of capacitance value. So you will have this green line alone running at 2 third value. Okay, this is the region of the saturation. Okay, and the third region of study is the linear region. In the linear region, you already know what is the value. The value is half of COX into WL for gate drain and half of COWX for gate source and gate drain respectively. So the value is half. This is the half value, and this is the region. Okay, so please be have a general analysis. You will be deriving this, and you will be writing the second question. Is this the same question you will be doing it? But please have an idea, because they might give you the graph and they will ask you which is the cutoff region in the graph, which is the saturation region, or which is the linear region. So this can be asked as a question for your exam. Okay, or this can be given also as a match. They can ask you to match the values for which region, what is the capacitance. Okay, so you should be able to keep these values in your mind so that you can analyze it. It's basically, if you understand the concept, it's very simple to analyze it. All right, is that clear so far? So this is how you analyze the effect of mass capacitance in the various regions of operation, right? So with that, we complete the topic on effect of mass capacitance. Now we'll go to the next topic, that is junction capacitance. With that, we'll close for today's class. Now, when you look at junction capacitance, in the junctions you will have capacitance. Okay, let's take one particular region. This particular region. Look at this particular region. It's a rectangle, right? What is the area of rectangle? Formula to calculate the area of rectangle. What is the formula used to calculate the area of a rectangle? I'll go with a new person. Gilbert Anto. Gilbert. Gilbert Anto. Are you there? Gilbert, can you tell me what is the formula used to calculate the area of a rectangle? Gilbert Anto. Gilbert, you're there? Please respond. You don't have much time. Just I've got 5 minutes more. Fast. Yeah, right, Hema. It's L into B. All of you know it. It's length into the breadth, right? So we'll be finding out what is the area. Look at this. This has got one, two, three, four. Four walls. Okay. Four junctions are there. And that is the fifth one in the center. Okay. In the five junctions, this is called sidewall. 1, 2, 3, 4 are sidewall junction capacitance. CJSW. Okay, and the bottom one is the junction capacitance, right? So the length of this thing is W, and the breadth is XJ. Okay, this also got this length as this is length, width, and height. Okay, so Y, XJ, and W. Okay, now we'll try to calculate what is the area. For example, what is the area of the junction 1? The area of junction 1 is, the length is W, this is the W, and the height is X. Okay, so the area of junction 1 is W into XJ. Is that clear? For this particular region, what is the area? The area is W into XJ. This W is the length and this is the breadth, right? What about region 2? What about region 2? Uh, Gopika, 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 you're there? Gopika, which is the length of the junction 2? What is the length of junction 2? Length, ma. What would be the length of junction 2? Junction two's length, ma. This is the area you have to calculate. Now, what is the length? Think, Gopika. Look at the picture. For one junction, I told you W is the length and X is the breadth. For second region or second junction, what would be the length? Y. Hema, that's right. Y is the length. Okay. And X is the width. Is that clear, Gopika? So the area is nothing but W Y into XJ. Okay. Please be careful. They can give you like this. Even the gate, they give you questions like this. And they ask you what is the area of that particular junction. Right. I'm just pictorially giving it. They can twist it in any way they want it. Right. So for the region 3 or junction 3, what is the area? It is going to be W into XJ. Okay. For the junction 4, it is Y into XJ. Okay. Now I want Mr. Who's the next person there? Yeah, I'll pick up Mr. Yeah, Lakshman. Lakshman. Lakshman, are you there? Can you unmute? Lakshman? Okay, Lakshman, what would be the area? I didn't find your problem when you're answering your attendance, Lakshman. Okay, go ahead. Tell me what is the area? Area of 5, that is this region. What would be the length and what is the breadth? W, Lakshman, what is W? W is the length. Okay. Then what is the breadth? W is the length. What is the breadth? My God, what is this? X W. Oh, X into, okay, W into Y. Is that I interpret like that? That's right, Lakshman. It's W into Y. That is the total area of the side wall junction capacitance. Okay, and there are layers also there which you have to learn. This is N plus. N plus is the region over here, and you have P junction transistors. Okay, that is only in this side walls because this is P region and this is N region. Okay, the drain is the N region and P is the positive in the holes in the gate region. Okay, the other will have P plus regions because we don't know what is the holes static value there. So all these are charged particles, and here you have pulse. Okay, so this is the region, and this is how you estimate the area of the junction capacitance, right? So we'll wind it up for this class. Thank you. So what we learned today is we have analyzed what is the effect of MOS capacitance, and then we saw what is junction capacitance, what is sidewall capacitance, and what is junction capacitance, and how do you estimate the area. Okay, so next class we will see in detail about the other concepts involving the analysis of junction capacitance and zero bias junction capacitance. All those capacitance effects we will analyze in next class, right? Thank you for your patient listening. You can learn more. Thank you.
Sir, you will. Hello, sir.